Item 416. Drilled shaft foundations. 1. Description. Construct foundations consisting of reinforced or non-reinforced concrete drilled shafts. 2. Materials. Use materials that meet the requirements of the following items. Item 421, hydraulic cement concrete. Item 440, reinforcement for concrete, and Item 448, structural field welding. Use concrete for drilled shafts that meets the requirements of Table 1 unless otherwise shown on the plans. Table 1. Concrete for drilled shafts. Drilled shaft type and concrete. Non-reinforced has a concrete classification of Class A. Reinforced has a concrete classification of Class C. Slurry and underwater concrete placement has a concrete classification of Class SS. Use coarse aggregate grade 4, 5, or 6 for drilled shaft concrete in reinforced drilled shafts. Grade 2 or may 3 be used if the shaft is dry and reinforcing steel has a 5 inches minimum clear spacing. Use a water-reducing, retarding admixture in accordance with DMS 4640, chemical admixtures for concrete, in all concrete when using casing that will be pulled or when placing shafts underwater or under slurry. Use concrete with slump that meets the requirements of Table 2 as determined by TEX 415A. Table 2. Slump requirements. See table in specifications. Perform a slump loss test in accordance with TEX 430A before beginning work when casing is to be pulled or concrete is to be placed underwater or under slurry. Provide concrete that will maintain a slump of at least 4 inches throughout the entire anticipated time of concrete placement. Time of concrete placement is described in Section 416.3.6, Concrete, and Section 416.3.7, Additional requirements for slurry displacement or underwater concrete placement methods. Note the temperature of the concrete mix at the beginning of the slump loss test. Place the concrete if its temperature at the time of placement into the drilled shaft is no more than 10 degrees Fahrenheit higher than the slump loss test temperature. Use ice or other concrete cooling ingredients to lower concrete temperature, or run additional slump loss tests at the higher temperatures. Slump loss testing will be waived if anticipated time of concrete placement is less than 90 minutes. Use mineral drilling slurry that meets the requirements of Table 3, as determined by TEX 130E. Determine pH of slurry by TEX 128E or pH paper strips. Table 3. Mineral slurry requirements. See table in specifications. Use mineral slurry consisting of processed bentonite or attapulgite clays mixed with clean fresh water. Do not use partially hydrolyzed polyacrylamide, PHPA, polymeric slurry or any blended mineral polymer slurry. If approved, water may be used as the drilling fluid. In this case, all of the provisions of Table 3 must be met except that the maximum specific gravity is not to exceed 1.12. Sample slurry from the bottom of the hole, before placing concrete, and test it in accordance with TEX 130E. Use a pump or air lift to remove slurry that does not meet the requirements of Table 3 while adding fresh clean slurry to the top of the hole to maintain the slurry level. Continue this operation until the slurry sampled from the bottom of the hole meets the requirements. 3. Construction. Submit drilled shaft installation plan for review no later than 1 month before drilled shaft construction. Include the following in the plan. Name and experience record of the drilled shaft superintendent who will be in charge of drilled shaft operations for this project. List of proposed equipment to be used, including cranes, drills, augers, baling buckets, final cleaning equipment, desanding equipment, slurry pumps, core sampling equipment, tremes or concrete pumps, casing, etc. Details of overall construction operation sequence and the sequence of shaft construction in bents or groups. Details of shaft excavation methods. When the use of slurry is anticipated, details of the slurry mix design and its suitability for the subsurface conditions at the construction site, mixing and storage methods, maintenance methods, and disposal procedures. Details of methods to clean the shaft excavation. Details of reinforcement placement, including support and centralization methods. Details of concrete placement, including proposed operational procedures for free fall, TxDOT, or pumping methods. Details of casing installation and removal methods. The installation plan will be reviewed for conformance with the plans, specifications, and special provisions. The contractor will be notified within 14 days of receipt of the installation plan of any additional information required and/or changes necessary to meet the contract requirements. All procedural approvals given will be subject to trial in the field and will not relieve the contractor of the responsibility to satisfactorily complete the work as detailed in the plans and specifications. Place the shaft to within the following tolerances. Vertical plumbness 1 inches per 10 feet of depth. Center of shaft located under column 1 inches of horizontal plan position. Center of shaft located under footing 3 inches of horizontal plan position. Complete the embankment at bridge ends before installing drilled shafts that pass through the fill. Refer to item 423, retaining walls, for provisions for drilled shafts passing through the structural volume of retaining walls. 3.1 Excavation. The plans indicate the expected depths and elevations for encountering satisfactory bearing material. Excavate as required for the shafts through all materials encountered to the dimensions and elevations shown on the plans or required by the site conditions. Removal of man-made obstructions not shown on the plans will be paid for in accordance with Article 9.7, Payment for Extra Work and Force Account Method. Adjust the bottom of the shaft or alter the foundation if satisfactory founding material is not encountered at plan elevation, as approved to satisfactorily comply with design requirements. Blasting is not allowed for excavations. Stop drilling if caving conditions are encountered, and adopt a construction method that stabilizes the shaft walls. Do not excavate a shaft within 2 shaft diameters, clear, of an open shaft excavation, or one in which concrete has been placed in the preceding 24 hours. Dispose of material excavated from shafts and not incorporated into the finished project in accordance with the plans and with federal, state, and local laws. Provide suitable access, lighting, and equipment for proper inspection of the completed excavation and checking the dimensions and alignment of shafts excavation. 3.2 Core holes. Take cores to determine the character of the supporting materials if directed. Use a method that will result in recovery of an intact sample adequate for judging the character of the founding material. Such cores should be at least 5 feet deeper than the proposed founding grade or a depth equal to the diameter of the shaft, whichever is greater. Take these cores when the excavation is complete. 3.3 Casing. Use casing when necessary to prevent caving of the material, to exclude groundwater, when slurry is used for hole stabilization, or when required as part of the contractor's safety plan. Provide casing with an outside diameter not less than the specified diameter of the shaft. The portion of shaft below the casing may be as much as 2 inches smaller than the specified shaft diameter. No extra compensation will be made for concrete required to fill an oversized casing or oversized excavation. Use casing strong enough to withstand handling stresses and pressures of concrete and of the surrounding earth or water, and that is watertight, smooth, clean, and free of accumulations of hardened concrete. Use construction methods that result in a minimal amount of disturbed soil being trapped outside the casing. This does not apply to temporary undersized casings used to protect workers inside shafts or to drilled shafts designed for point bearing only. Leave casing in place only if authorized or shown on the plans. Extract casing only after placing the concrete to an appropriate level. Maintain sufficient concrete in the casing at all times to counteract soil and water pressure. Rotate or move the casing up or down a few inches if necessary before and during concrete placement to facilitate extraction of the casing. 3.4 Requirements for slurry displacement method. When soil conditions warrant, use the slurry displacement method to construct drilled shafts unless otherwise shown on the plans. Use this method to support the sides of the excavation with processed mineral slurry that is then displaced by concrete to form a continuous concrete shaft. Install surface casing to a minimum of 10 feet below existing ground before introducing slurry. Do not use casing other than surface casing. Do not use surface casing longer than 20 feet without approval. Do not extract the surface casing until after placing the concrete. Premix slurry in a reservoir with enough capacity to fill the excavation and for recovery of the slurry during concrete placement. Do not mix slurry in the shaft excavation or other hole. Allow adequate time for hydration of the slurry before introduction into the excavation. Maintain a head of slurry in the shaft excavation at or near ground level or higher, as necessary, to counteract groundwater pressure during and after drilling. Use an airlift or proper size cleanout bucket, just before placing reinforcing steel, to remove any material that may have fallen from the sides of the excavation or accumulated on the bottom after the completion of drilling. Use a cleanout bucket if material is too large to be picked up with an airlift. Reprocess the hole with the auger as directed if concrete placement is not started within 4 hours of the completion of the shaft excavation. Then clean the bottom with an airlift or cleanout bucket, and check the slurry at the bottom of the hole for compliance with the slurry requirements of Article 416.2, Materials. Agitate the congealed slurry to liquefaction if the slurry forms a gel before concrete placement, and whenever directed. Recover and dispose of all slurry as approved, and in accordance with all federal, state, and local laws. Do not discharge slurry into or in close proximity to streams or other bodies of water. 3.5 Reinforcing steel. Completely assemble the cage of reinforcing steel, and place it as a unit immediately before concrete placement. The cage consists of longitudinal bars and lateral reinforcement, spiral reinforcement, lateral ties, or horizontal bands. Connect individual segments with couplers or by lapping steel as approved if overhead obstacles prevent placement of the cage as a single unit. Extend the reinforcing steel cage as follows if the shaft is lengthened beyond plan length unless directed otherwise. Extend the cage to the bottom for shafts supporting structures other than bridges. Extend the cage to 25 feet or to the bottom, whichever is shorter, for bridge shafts with plan lengths less than 25 feet. Do not extend the cage for bridge shafts with plan lengths at least 25 feet that are lengthened less than 33% of plan length. Extend the cage as directed for bridge shafts with plan lengths at least 25 feet that are lengthened more than 33% of plan length. If the cage does not reach the bottom of the shaft, it may be suspended, or a portion of the longitudinal steel may be extended to support the cage on the bottom of the shaft. Bars used to extend or support the cage may be lap spliced or welded by a qualified welder. Place the extension at the bottom of the shaft. Tie spiral reinforcement to the longitudinal bars at a spacing no more than 24 inches, or as required for a stable cage. Ensure lateral reinforcement is not welded to longitudinal bars unless otherwise shown on the plans. Center the reinforcing steel cage in the excavation using approved roller-type centering devices unless otherwise approved. Use concrete or plastic chairs to keep the reinforcing cage off of the bottom of the hole. Use centering devices starting at 1.5 feet off from the bottom of the cage and spaced vertically at intervals not exceeding 10 feet. Use a minimum of 3 centering devices per level at a spacing not to exceed 30 inches. Flat or crescent-shaped centralizers, sleds, are not allowed. Support or hold down the cage to control vertical displacement during concrete placement or extraction of the casing. Use support that is concentric with the cage to prevent racking and distortion of the steel. Check the elevation of the top of the steel cage before and after concrete placement or after casing extraction when casing is used. Downward movement of the steel up to 6 inches per 20 feet of shaft length and upward movement of the steel up to 6 inches total are acceptable. Maintain the minimum length of steel required for lap with column steel. Use dowel bars if the proper lap length is provided both into the shaft and into the column. Locate and tie all dowel bars into the cage before placing concrete or insert dowel bars into fresh, workable concrete. Locate and tie anchor bolts when required before placement of concrete. Use templates or other devices to assure accurate placement of anchor bolts. 3.6 Concrete. Perform all work in accordance with item 420, concrete substructures. Provide concrete with maximum placement temperatures as specified in Table 4. Provide thermal analysis to show and temperature recording devices to verify maximum core temperature requirements are met as specified in Section 420.4.7.14, mass placements, as directed. Table 4. Maximum concrete placing temperature. See table in specifications. Form portions of drilled shaft that project above natural ground. Remove loose material and accumulated seep water from the bottom of the excavation before placing concrete. Place concrete using underwater placement methods if water cannot be removed. Place concrete as soon as possible after all excavation is complete and reinforcing steel is placed. Provide workable concrete that does not require vibrating or rotting. Vibrate formed portions of drilled shafts. Place concrete continuously for the entire length of the shaft. Limit free fall of concrete to 25 feet for dry shafts of 24 inches or smaller diameter. Use a suitable tube or tremie to prevent segregation of materials. Use a tube or tremie in sections to provide proper discharge and permit raising as the placement progresses. For dry shafts over 24 inches diameter, concrete can be allowed to free fall an unlimited distance if it does not strike the reinforcing cage or sides of the hole during placement. Provide a hopper with a minimum 3 feet long drop tube at the top of the shaft to direct concrete vertically down the center of the shaft when free fall is used. Do not use a shovel or other means to simply deflect the concrete discharge from the truck. Maintain a sufficient head of concrete for cased shafts at all times above the bottom of the casing to overcome hydrostatic pressure. Extract casing at a slow, uniform rate with the pull in line with the axis of the shaft. Monitor the concrete level in the casing during extraction. Stop the extraction and add concrete to the casing as required to ensure a completely full hole upon casing removal. The elapsed time from the mixing of the first concrete placed into the cased portion of the shaft until the completion of extraction of the casing must not exceed the time for which the concrete maintains a slump of over 4 inches in accordance with Article 416.2, Materials. Modify the concrete mix, the construction procedures, or both for subsequent shafts if the elapsed time is exceeded. Cure the top surface and treat any construction joint area in accordance with item 420, concrete substructures. 3.7 Additional requirements for slurry displacement or underwater concrete placement methods. Place concrete on the same day the shaft is excavated and as soon as possible after all excavation is complete and reinforcing steel is placed. Use an airlift or clean-out bucket of the proper size to clean the bottom of the excavation before placing the reinforcing steel cage and concrete. Place concrete through a closed tremie or pump it to the bottom of the excavation. The minimum tremie diameter will be at least 6 times the maximum size of aggregate used in the concrete mix but not less than 10 inches. Initially seal the tremie or pump line to positively separate the concrete from the slurry or water. Place concrete continuously from the beginning of placement until the shaft is completed. Keep the tremie full of concrete and well submerged in the previously placed concrete at all times if using a tremie. Raise the tremie as necessary to maintain the free flow of concrete and the stability of any casing used. Keep the discharge tube submerged in the previously placed concrete at all times if using a pump. Place additional concrete to ensure the removal of any contaminated concrete at the top of the shaft. Allow the top portion of concrete to flush completely from the hole at the completion of the pour until there is no evidence of slurry or water contamination. Do not attempt to remove this concrete with shovels, pumps, or other means. Level the top of shaft with hand tools as necessary. Use a sump or other approved method to channel displaced fluid and concrete away from the shaft excavation. Recover slurry and dispose of it as approved. Do not discharge displaced fluids into or near streams or other bodies of water. Provide a collar or other means of capturing slurry and the top portion of concrete flushed from the shaft for pores over water. Remove the tube, reseal it at the bottom, penetrate with the tube into the concrete already placed by at least 5 feet, and recharge it before continuing if concrete placement is interrupted due to withdrawal of the submerged end of the tremie or pump discharge tube before completion. If this condition exists, notify the engineer and note the elevation and circumstances related to the loss of seal on the drilled shaft log. The elapsed time from the mixing of the first concrete placed until the completion of concrete placement, including extraction of the casing, must not exceed the time for which the concrete maintains a slump of over 4 inches in accordance with Article 416.2, Materials. Modify the concrete mix, the construction procedures, or both for subsequent shafts if the elapsed time is exceeded. 3.8 Test load. Load test shafts, if required, in accordance with Item 405, Foundation load test. 3.9 Trial shaft. When required on the plans, construct trial shafts to the depth and diameter specified on the plans. Trial shafts include drilling the hole, placement of the rebar cage, unless otherwise stated, and placement of the concrete. When trial shafts are required, delay start of production shafts until successful completion of trial shafts. 4. Measurement. 4.1 Drilled shaft. Drilled shaft foundations will be measured by the foot to the bottom of the shaft. 4.1.1 Interior bents and piers. Shafts will be measured from a point approximately 6 inches below the finished earthwork elevation at the center of each shaft, unless specific elevations or dimensions are indicated on the plans or unless otherwise directed to meet unusual conditions. The bent height shown on the plans is for estimating purposes only and does not control the top of shaft measurement. 4.1.2 Abutment bents and retaining walls. Shafts will be measured from the bottom of footing or cap elevation. 4.1.3 Other non-bridge structures. Shafts, including trial shafts, will be measured from the top of the shaft. 4.2 Core hole. Core holes will be measured by each core hole drilled. 5. Payment. The unit prices bid for the various classifications of drilled shafts will be full compensation for excavation, furnishing, placing and removing casing, furnishing, processing and recovering slurry, furnishing, and placing reinforcing steel, pumping, furnishing and placing concrete, including additional concrete required to fill an oversize casing or oversize excavation, conducting slump loss tests, backfilling, disposing of cuttings and slurry, and materials, tools, equipment, labor, and incidentals. When the bottom of a drilled shaft is placed at an elevation below plan grade, no direct payment will be made for extra reinforcement placed to support the cage. The extra reinforcement will be considered subsidiary to the price bid per foot of shaft. No extra payment will be made for casings left in place. No payment will be made for drilled shaft until the concrete has been placed. 5.1 Drilled shaft. The work performed and materials furnished in accordance with this item and measured as provided under measurement will be paid for at the unit price bid for drilled shaft, non-reinforced, drilled shaft, sign mounts, drilled shaft, high mast pole, drilled shaft, roadway illumination pole, or drilled shaft, traffic signal pole, of the specified diameter, subject to the limitations for overruns authorized by the engineer given in Section 416.5.1.1, Overrun. 5.1.1 Overrun. Payment for individual completed shaft lengths up to and including 5 feet in excess of the maximum plan length shaft, as defined in Section 416.5.1.2, maximum plan length shaft, will be made at the unit price bid per foot of the specified diameter. Payment for the portion of individual completed shaft length in excess of 5 feet and up to and including 15 feet more than the maximum plan length shaft, as defined in this item, will be made at a unit price equal to 115% of the unit price bid per foot of the specified diameter. Payment for the portion of individual completed shaft length in excess of 15 feet more than the maximum plan length shaft, as defined in section 416.5.1.2, maximum plan length shaft, will be made at a unit price equal to 125% of the unit price bid per foot of the specified diameter. 5.1.2 Maximum plan length shaft. Payment described above is subject to the following provisions for extra depth drilling. For bridge structures, the maximum plan length shaft is the maximum length shaft, regardless of diameter, for any drilled shaft on that specific bridge. For retaining walls, the maximum plan length shaft is the maximum length shaft, regardless of diameter, for any drilled shaft on that specific retaining wall. For overhead sign structures, the maximum plan length shaft is the maximum length shaft, regardless of diameter, for any overhead sign structures included in the contract. For high-mast illumination poles, the maximum plan length shaft is the maximum length shaft, regardless of diameter, for any high-mast illumination pole included in the contract. For roadway illumination poles, the maximum plan length shaft is the maximum length shaft, regardless of diameter, for any roadway illumination pole included in the contract. For traffic signal poles, the maximum plan length shaft is the maximum length shaft, regardless of diameter, for any traffic signal pole included in the contract. 5.2 Core hole. Core holes will be paid at $200 each.